Wonderful. Hello, good afternoon, and welcome to another HRAI webinar. My name is Matthew Bradford. I'm your webinar host and co-organizer. Sorry, it's one of those days. And today I am proud to be presenting alongside Jeanine Jollineau, Ontario Building Code 2024 HVAC changes. A webinar that's bound to have a lot of questions, which we're going to save towards the end. So at this point, I would like to introduce Jeanine, who's going to be presenting the show. There she is.
Good afternoon.
After a rough start, I'm sure you're going to make this a lot more professional and do your thing. But thank you so much for joining us. And like I said, we're going to have questions at the end of this presentation, which I will pop back on and do with you. Otherwise, this is being filmed or recorded, and you can find it on HRAI's webpage or YouTube page after the fact. Other than that, I'm going to leave it over to you and fall into the back here. Cheers.
Okay. Thanks, Matt. I'm just going to share my screen. And what we'll be covering today is and I just want to make sure I get myself on the right view too. I want to see that. Okay, good. So what we'll be covering today are the highlights specifically related to 9.32 in the Ontario Building Code. So I assume if you're in this webinar today, you're currently an HVAC practitioner or someone in the industry that has gotten wind of the fact that in January we adopted the National Building Code 2020 in Ontario, and now we've got some new rules to follow and some different methodology in terms of our ventilation design. So that's what this webinar is about. The next one coming up on Thursday will cover the rest of the things that are new for HVAC systems, and we'll hit on part 6 and the rest of part 9, and I think we even cover the new part 2. There's a couple other little minor things there too. So yeah, so welcome. So we'll get right into it. I always like to just say, what if I happen to express an opinion, it's mine. It's not HRAI or the HVAC Designers of Canada necessarily. And of course, the big thing is I've done my very best to get all the code changes in here and make sure everything's accurate. But of course, do your own due diligence. And I will have an ending slide where you can get a copy of the code and, of course, more information about training if you think you do need a little more of that. So my name's Jeanine Jollineau, and I am an HVAC designer. I've been I started off in my career for about 20 years as an HVAC contractor in residential new construction in Ottawa. And now I'm designing. I've been doing that since about 2007. And I've logged over 3,300 projects. I think I'm almost at the end of getting to 3,400. So it's been a long road, and for the last 5 years, I've been teaching for HRAI, the ventilation courses, and small commercial air system design. I'm on the board of directors for the HVAC Designers of Canada. That's just since last year. And I'm also a ground source heat pump designer and soon to be a trainer in those programs as well. That's a big passion of mine. So you're probably wondering a little more about HVAC Designers of Canada. If you haven't heard of them, basically we're fairly new, and we are founded on the pillars of advocacy, quality, capacity building, and industry standards. And so we're really trying to bring what we have in Ontario through the implementation of the BCIN system to the rest of Canada. So we are working with people in Alberta. Later today, I'll be presenting to the South Vancouver Building Officials Association to try to, bring them on board to some of the things they might like to see in HVAC design for new building permits and sort of ease the path so that there's confidence in not only the quality of the work, but also in the availability of designers. So if you're a designer or you're thinking about that type of a career, stay tuned. It's a great time to be in this field. The key changes. So in red, I've noted the key changes. So if something's there in red, it's important. So getting on to it, as I say, we've harmonized with National Building Code 2020 as of April 1st. That was the hard start line where between January 1st and March 31st, you could still submit under old code because there were projects obviously in the hopper at the end of December that couldn't quite make it to application, but were already well developed and no need to go back and edit. So April 1st, however, was the end of that grace period. So here we are. So the major change in 932 is that we have a new concept of non-heating season ventilation. So this applies to spaces that do not maintain occupancy in the winter months. Spaces are either cooled or not cooled and have different requirements based on that cooling provision. The ventilation rate is lower where spaces are cooled to reduce energy waste and reduce loading of the cooling systems. Homes with a heating system and electrical power will require heating season ventilation. So there's those two options. And usually that's the best approach for most homes. So if we take that approach, we're covering both scenarios. Another big change is secondary suites. Secondary suites had been included in the OBC 2012, and that was more or less to try to drive, some cohesion of or some ability for people to have secondary suites and combine HVAC systems. That's no longer a thing, so they must have independent, unique ventilation systems, and they're treated as completely independent dwelling units. This, of course, does not impact those homes that fall under Part 11. So Part 11 is our existing homes part of the code. And if you happen to have a home over 5 years old, meaning that occupancy permit was given more than 5 years ago, and it's going to be turned into a multi-unit project, then of course there is some sharing of systems allowed, and you can find the compliance alternative for that in Part 11. I'll have that in my next presentation. Common spaces. So common spaces in buildings that do have secondary suites, such as storage rooms, service rooms, laundry rooms, and hallways and corridors, do not require a ventilation system. So that makes it a lot easier for us. Usually these rooms have, access to exterior, some kind of natural ventilation. And so that just makes it a whole lot easier to keep the two systems unique. If you do have a situation where makeup air is required for any particular reason, and we will cover when that happens in just a bit of an overview a little bit later, then of course you also need to conform to 932.38. So the makeup air provisions, tempering and that type of thing, and pressure relief. When it comes to these common spaces, and in particular laundry rooms, the laundry drying equipment, when there are multiple dryers, was singled out uniquely in the Ontario Building Code to stay separate from NBC 2020 with different wording. However, the wording pretty much means the same thing. So you do need to have a common duct connected to one central fan, one central lint trap. It should be the laundry drying equipment should be interlocked so that the fan activates with one or more dryers in use. And of course, makeup air is required with specific tempering and returning air to the spatial location of the dryer or exhaust extraction. So if you do get into multiple dryer systems, it does get a little tricky with the electrical requirements to try to make that happen as described. But it is still fairly rare that we see that even in multi-unit residential. They're often individual dryers ducted to the exterior. Another big change would be in the storage garages. So in the past, we would say you could have up to 5 vehicles or 5 parking spaces indoors and be considered following Part 9 as it is. but now that number's been reduced to 4. So if there are 5 or more parking spaces in the garage or 5 or more vehicles being stored, then this becomes a Part 6 design, which means you will need to incorporate carbon monoxide monitoring or nitric oxide, nitrous oxide. I'll have to find the proper wording for that. Sorry, or NO monitoring. So if you have a diesel vehicle, diesel fueled vehicle, then it would be the NO that we're monitoring. So either way, you have to have something like that, which means, air extraction systems, makeup air, alarms, and the whole bit. So it gets a lot more elaborate. So the car collectors will be down to 4 or implement a system for this. So over to back to the code issue. So that's the general overview of the things that have changed. Now we dive into non-heating season ventilation. And we're just going to go through the code, pretty much in numerical order and pick out all the things that are new and all the details. So as before, if we were using a table for natural ventilation, you might recall bathrooms and water closet rooms, you needed to have, and I use the imperial numbers, 0.97 square feet. Unfinished basement was 0.2% of the floor area. And then all the other finished rooms for habitable purposes were 3 square feet per room or combination of rooms. So we had that table. And then from there, so that's still all in effect, which, this is talking, when we're talking natural ventilation, we're talking about windows and doors, right, that open to the exterior and how big those openings are. If there is a desire to have mechanical ventilation, or if there is no natural ventilation, so the room does not have a window or door, then you can provide mechanical ventilation to make up for that. And then there are 2 options, and that is, is it mechanically cooled? If yes, then you follow a table. If no, then you provide 1 air change per hour. So then you'd need the volume of the room to calculate that. If you're looking at the table, you might recognize this table. This was our old, what we used to call total ventilation capacity table. But now we won't see it any other time but in the non-heating season ventilation part of 932. The same footnotes apply. So the concept of you have to designate one room as a master bedroom, and what else? I guess any access rooms, egress rooms are not included. All those little details are the same as before. And don't forget, this table is in metric, so 1 liter per second is 2 cubic feet per minute. That's our soft rounding. So it's double that for your imperial numbers. Then we go to heating season ventilation. So we jump right out of it. We've done non-heating season. Now we're right into the real deal. So this is for dwelling units with 5 or fewer bedrooms. If you get into 6 bedrooms, then of course you go into Part 6, and then you're into other alternatives such as the CSA F326 standard, which will certainly accommodate you with that. National Building Code 932 is very similar to that standard, just a little more simplistic and prescriptive. So it's meant really to be the layman's version of F326. There are 3 essential parts to a mechanical ventilation system. You have your principal ventilation system, and that's an exhaust and sometimes maybe a supply, supplemental exhaust fan or fans, and protection against depressurization. So if we take the first essential, the principal ventilation system, we'll look at that. And that has 3 components, including the indoor air exhaust, the outdoor air supply, and some kind of distribution of air. So when we start off with analyzing our principal ventilation, we have to figure out what sort of rate of ventilation we're looking for. So table 932.33 has those minimum and maximum principal exhaust fan capacities. So you can see that if we look at a standard 3-bedroom home, We've got a range of 44 to 64 cubic feet per minute. In the old standard, we would use 30 liters per second, 60 CFM for a 3-bedroom home. So the numbers are very, very similar to what we were using before, except that now we have a range. If you're doing a heat loss and cooling load, typically we would use the maximum number in the range. So if I'm doing a 3-bedroom home, I'm going to be using 64 in my heat loss cooling load calculations. As far as supply air goes, so that's our main principal exhaust fan. That's a must-have. As far as our supply goes, that's a maybe. So we can depressurize with our exhaust fan if we prefer to, but we could also introduce supply. And I know some of you are saying, but wait a minute, don't we have to have an HRV? That's not 932, but yes, SB 12 does require that for almost every prescriptive package. So unless you're going to do performance modeling and, or unless you, for some reason feel you don't need one with the and want to undertake the modeling, then of course that might be the case. But we're just going to follow through the code the way it's written so that you can understand what's being said here. So whenever you have a spillage susceptible appliance installed in a dwelling unit, including a wood burning appliance, then you must have the fresh air component. So we've got mechanical exhaust, we'll need to have mechanical fresh air. And of course we also need it when there is no forced air for the distribution of the fresh air. And then of course it makes sense that we should try to match our supply air with our principal exhaust airflow, and in fact it must match within 10%. If you're not using an HRV or ERV, then this supply air will need tempering to limit the mixed air temperature to 15 Celsius. So if you're providing it to, say, for example, a forced air system, and you'll need to calculate a mixed air temperature and keep it under 15. Whenever you're operating at the ventilation fan rate. So that means either your principal exhaust fan capacity, if that's your capacity, or if you're using a much larger volume than whatever that volume is that you're actually considering for your principal exhaust fan. So it could be a supply fan, it could be a supply intake. There are more details, of course, in this part of the code, but it's a rare case for Ontario, so we're not going to cover all those little details today. In general, as I mentioned, owing to SB 12, we're looking at an HRV or ERV to accomplish these goals. So if we have a forced air system, then and if that outdoor air supply is attached to the forced air system, then it has to be a fan that's rated for outdoor use if the air is not tempered ahead of the fan, rated for continuous use, and designed to match the principal exhaust fan capacity plus or minus 10%. It should be interlocked with the furnace fan and interlocked with the principal exhaust fan. So if you decide to have, as I mentioned, the two separate fans, this is the requirement. Therefore, of course, we come back to the HRV, ERV as being our best choice. So if the supply air fan is the supply side of an HRV, then the HRV must be interlocked with the furnace fan. And that really should be in red because that's a new thing. It's always been good engineering practice to connect your HRV and your distribution system, your forced air system together electrically so that when one calls, the other is moving as well. But it hasn't actually been a code requirement until now. So it is. So do make sure if you're designing, get that into your reports, into the comments, so that people don't miss that part because it will be required. If we're doing outdoor air supply without forced air, then the principal ventilation supply fan must match the principal exhaust fan capacity plus or minus 10%, and it must be measured and balanced with a device having a plus or minus 15% accuracy. So most of the digital manometers do have that type of accuracy. And if the principal ventilation supply fan is not an HRV or ERV, then the air must be tempered for delivery to at least 12 Celsius. It could be therefore a standalone central fan, Or again, we're back to the HRV, ERV possibility. So that's our supplier, and the next piece gets into distribution. So without forced air, ventilation supply air must be provided to every bedroom, every story without a bedroom, including basements and crawl spaces. And if there is no story without a bedroom, the principal living area. So we've heard that one before. If the air is being removed from a multi-room living area, that includes a kitchen exhaust in a kitchen living dining room combination arrangement, and the system includes 2 or fewer other room intakes, then the living room supply outlet is not required. So again, something entirely new, pointing us, to the fact that we can take out that principal living area if we're already removing air from the kitchen and it's all one room. So to illustrate that, I have a little layout here. This is a sample. In this case, it's just a small dwelling unit. It's actually an accessory dwelling unit. And this is the Ontario Building Code 2012 version. So it's actually, in this case, it was a detached garage that they converted to a residential unit. It has ductless mini splits. So you can see the mini splits here. There's one, and there's one in each bedroom, one in the living room, and baseboard heaters. So all the rooms have baseboard heaters as well. So we've got a non-forced air heating and cooling system. We're going to need a ventilation system to go with it. So our HRV is here in our little laundry and mechanical room. And we've got an intake in the kitchen, an intake in the laundry room, intake in the bathroom. So all three of those are the dark purple color representing exhaust air. And then of course our fresh air is the green color. We've got a fresh air outlet in this bedroom. We come across in a bulkhead and deliver to the master bedroom, and then again over in a bulkhead to hit the bedroom across the way and the living area. So what we're saying in the new code is you'll no longer need supply outlet 4 here because you've got the air intake here. And so the theory being that, from virtually every other point in the dwelling unit, fresh air is being delivered, and it should still sweep through the space with some degree of, effectiveness. So S4 can come out. That means the bedrooms will get a little more air and perform a little bit better. And so just if you're doing these designs, just know that you can eliminate that one should you choose to, as long as you have at least 2 other intakes, right, which we have here. Let me go back to that wording too. I want to make sure we repeat that. So the system includes 2 or fewer other room intakes, so maximum of 2 intakes. So if we get to too many more, then we're not getting an effective flush through the kitchen area anymore, right? If we have too many others. So this is the type of scenario that this is designed to deal with. So that's that. Exhaust only ventilation. So exhaust only ventilation still allowed, and I will just cover it slightly because this could also be a method, a strategy that you use for additions and renovations. So it is really relevant to new building permits in that sense. But because we've got an energy efficiency piece of the code, the SB12 component, of course, it eliminates the exhaust only ventilation virtually by claiming that you need, stating that you need an HRV with a specified efficiency. Because we're harmonizing with NBC 2020, other provinces do, some of them do still allow exhaust only ventilation. So because of that harmonization, it's still available to us as well. So in new construction, it's allowed, and of course I'm just going to read the slide there, but I basically just said that. So if a new house contains any of these 3 items, exhaust only is not allowed. So we're back to that solid fuel appliance. So wood burning fireplaces, wood stoves, pellet stoves fall into that same category. That's a solid fuel appliance. You can't have exhaust only ventilation. So pressure is an issue, and that's how we deal with pressure. A non-direct vented gas fireplace, also a problem. A fuel-fired water or space heating appliance that is not direct vent or mechanically vented. So anything B-vent, if there's still stuff out there, and I know there are. However, when we get into these in renovations and so on, oftentimes they're replaced for direct vent appliances. So if any of these are involved, then of course exhaust air is not allowed. But if it is allowed, then you must use a forced air system that moves at least 5 times the principal exhaust fan's normally operating exhaust capacity. You need to interlock it to the forced air system at that 5 times airflow rate. And then there's an option as well to use a timer for the forced air system as an alternative to the interlock, which means you could have, essentially you're shooting for some kind of time-weighted average where you're getting ventilation distribution using that forced air fan. So the concept being that, let's just say, for example, in our 3-bedroom home, we have a principal exhaust fan that's 64 cubic feet per minute, or let's call it 60 to make the math a little easier. If we decide that we're going to use that in conjunction with our forced air heating system, we'll need to set the forced air to a minimum of 300 cubic feet per minute, so 5 times our principal exhaust fan capacity, and make sure that it's interlocked to run at that speed. So they want to make sure that the fresh air that's coming in from all of the nooks and crannies in the building envelope, all the cracks and crevices, because that's the way exhaust-only ventilation works, that it's able to come in and then be mixed up within the house, so that rooms that don't have exposure to exterior walls will still get ventilation, and rooms that have a lot of exposure won't have comfort, compromised by that, and some of that air picked up and moved around to the other spaces. So far, so good. The next piece of our heating season ventilation system is supplemental exhaust. So our kitchen comes first, and that's specifically stated that 100 CFM for either a range hood or a kitchen exhaust fan. The kitchen range hood cannot be the principal exhaust fan, and the main reason for that is on the next slide. So I won't I won't give it up just yet. Supplemental bathroom exhaust fans are specified as well at a minimum of 50 cubic feet per minute. So there's your two numbers, 150 for 50 for the bathrooms, 100 for the kitchen, spelled out for you in this version of the code. Both of these align with the CSAF 326 standard as well as the HRAI 62.2 standard. So whichever one you look at is all the same now. Now, kitchen exhaust fan is not required if all the air for the principal exhaust fan is taken from the kitchen. So you've got a recirculating range hood, in other words, non-ducted range hood, and 100% HRV intake, or the air for the principal exhaust is taken from the kitchen and other rooms, and the principal exhaust fan can be switched to a rate of 2.5 times the minimum principal exhaust fan capacity using a 2-speed fan or HRV ERV, and the higher exhaust rate is controlled by a switch in the kitchen labeled kitchen exhaust. This could be a manual switch for a 2-speed fan or an HRV ERV timer. Hopefully that makes sense. Basically just saying that, if you're going to go ahead and incorporate your HRV exhaust from the kitchen, and basically pulling from the kitchen, bringing it through the HRV, then you need to have 2.5 times the capability of your principal exhaust fan. So your 60 CFM times 2.5 is 160. Well, 64 would be 160, is 150. So somewhere in there is your requirement for your 2-speed HRV. So those numbers are a little bit higher. At the high end of the range, it would be 110. I've got it here on my desktop. I keep a little book of little things I need that I look up all the time. So I've got 110 to 160 based on 44 to 64 CFM as principal exhaust. So the numbers are, there's a low end of the range, but the numbers are pushing higher as well. So when you get to your 5-bedroom, you're in the 150 to 225 range. So you might see in some of your designs those ventilation rates creeping up, and you might find yourself selecting different HRVs to try to meet those higher requirements. So just the heads up. And then the reason why kitchen range hoods can never be principal exhaust fans is because a kitchen intake that is going to be used for principal exhaust that isn't a range hood must be at least 2 meters above the floor. If you're going to have, in other words, an HRV or ERV intake, it's got to be higher than the standard range hood height. And so therefore, the range hoods are just not high enough to be considered principal exhaust fans. I hope that wording is makes sense to you. And in Appendix A, you'll find several diagrams that interpret this subclause of 932. And of course, this means, yeah, I also want to point out in this slide that this does not mean that you can't have a kitchen range hood ducted to outside as a supplemental fan and an HRV that actually does have a larger capacity than your principal exhaust fan capacity. The point for the principal exhaust fan capacity is that one of the speeds of the HRV can hit that target. So, and that's more or less selected as your low speed. So if you decide I want to have 120 or 140 CFM in my layout, because I'm going to pull from a couple of bathrooms, maybe 2 or 3 bathrooms, or 4 bathrooms, and I want to have some air for each of those. I want to make it a little bit more than just the minimum, and make them work effectively. I'm going to leave out the kitchen, put in a range hood. Doesn't mean that you're limited with only the principal exhaust fan capacity to play with. In that case, you can make it what you want to make it. So there's a fair degree of flexibility here, as long as it does return to the lower setting. And of course, with the new, there are many new HRVs out on the market that are digitally balanced, and so we can really hone in on these numbers and set, a high and a low that are specific. Whereas in the non-digitally balanced units, of course, you're balancing on high and the low takes care of itself. So you don't really have an ability to hone in on the low unless the HRV itself actually has specific settings that you can choose. So just to know, always stay in contact with your installers and balancers, because they're going to help you as well shape the design. You want to make sure your design is friendly for them too. And now we move into our final piece, which is the protection against depressurization. So the old system of the house type, it's a type 1 home, it's a type 2 home, etc. Those things are not described at all in OBC 2024, so that's all out the window. When there are fuel-fired heating or hot water heating appliances that are not direct vent or mechanically vented, then any ventilation device beyond the principal exhaust fan must have a makeup air. So what we're saying here is, if it's not mechanically vented or direct vent, if you have a clothes dryer, if you have a range hood and they're vented to the exterior, then you, and it's not the principal exhaust fan, of course, because these are supplemental appliances, they will need makeup air. So it gets messy right away, which pushes us back to direct vented appliances, or, no combustion appliances, as in the case of heat pumps and so on. So this does not apply, however, to dwelling units with solid fuel-fired appliances. Providing all the other fuel-fired appliances are direct vent. So if you've got direct vent appliance plus a solid fuel-fired appliance, you don't need that makeup air provision. So it's only when you have a mechanically vented, but not mechanically vented and not direct vent appliance. So you got a B-vent appliance would be, I guess, the best example. You've got a gas log set with no glass. That would be a problem. Any of those are going to get, really sticky with makeup air. whereas the solid fuel is still being, given a little bit of grace, primarily because you have to actually, feed the fire, right? You have to. There's a human involved in this. They're not, normally thermostatically controlled and just left to operate without someone being there. So that's the main reason that they're sort of seen as a decorative intermittent appliance. So that gets a little bit confusing. So when you get into your first wood burning appliance design, do go back and just reread everything to make sure you understand what's going on. It's very similar to what we were doing before in the old code. It's just the writing is a little bit different. If we do get into makeup air, 93238, our makeup air should be at least the capacity of the exhaust device and not more than 10%. So they don't want it to exceed we don't want to be pressurizing the house with our makeup air. So you don't want to exceed your exhaust device. Interlock to the exhaust device just makes sense. One comes on, it tells the other one to come on. And you'll need to temper that makeup air to 12 degrees Celsius. If you're using a fan, you will need to make sure it's rated for outdoor use if the tempering takes place after the fan. And designers, of course, are encouraged because all of this makes it sound like you invent this makeup air yourself and you specify all of the components. But actually, there are off-the-shelf customizable makeup airs available. And that's actually going to protect you from any, risk of missing something in trying to put together some sort of field arrangement, field assembled arrangement. So have a look, talk to the wholesalers, and get a couple of makeup airs for small systems. They have them from 100 to 600 CFM type systems. Get those in your back pocket and specify those. That's the best way to go. An alternative to makeup air is the use of the CAN CGSB 51.71 depressurization test. HRAI does offer a course that covers that, and you could go ahead with that, but that may or may not just add complexity to the situation. A passive makeup air can also be used with a sensor and a heater. So it may not always need a fan for some small applications. So if you do get into those, I'm going to say under 100 CFM, if it's something small like that. I think once you get to about 150, the whole size starts to get a little big. You can use passive makeup air strategies as well. So that's it for makeup air. And we're going to move on to something new in 932, and that is carbon monoxide alarms. So this was formerly in, I think it was 939 or 940 of OBC 2012, and now they've brought it right into 932, which is a good place for it. We're certainly talking about ventilation and fuel-fired appliances here, so it just makes sense that the CO alarms are in the same place. So residential occupancies that have fuel burning appliances or a storage garage, or if they are served by, if they're an occupancy served by a forced air fuel burning appliance not contained in the building. So in other words, if it's some kind of secondary suite that maybe has a forced air system that's in a mechanical room that maybe serves both suites, so it's not actually in the suite. However, it would still require a CO alarm because failure of the heat exchanger could lead to the leakage of CO into the space. And then so there are some expanded details for other occupancies. There's also a lot of detail with sound and light requirements, so accessibility requirements for these CO alarms. So I do encourage you to go and take a look at 93239 because it is several pages of code that I really can't reproduce all of it here. And there will be, if this, then sort of decision making where you'll need to walk through your particular job and see if it requires, any special notes. When it comes to where they're installed, they should be adjacent to each sleeping room in the suite and on every story without a sleeping room. If a sleeping room contains a fuel burning appliance, or it's attached to a room that contains one, or a storage garage that is adjacent by virtue of an attic or crawl space linking the two, then it too must have one. So you're down to almost every sleeping room in the house. And every story without a sleeping room. Corridors that are heated by a fuel burning appliance require a CO alarm as well. So that, again, that's multi-unit residential where that might come into play. And just again, carefully read this section. And if you have any questions, either reach out to our technical department or speak with your local building official who may be able to decipher some of that for you. With time, we'll have it all. So some of the ratings are a little bit different as well. So our static pressure ratings for various fans in the ventilation system are as follows. If they are installed with ducts connected on both sides, like an HRV or ERV, we're looking at 0.4 inches of water column. So formerly we were looking at 0.2. Now that's been raised to 0.4. So that's the new numbers that'll go on your reports. Your mechanical ventilation design summaries will include the 0.4 number now rating. If they are fans that are installed with ducts on one side only, such as a bathroom fan or a range hood, we'll be looking at, a bathroom fan used as a principal ventilation fan. We're looking at 0.25 inches of water column. For all other fans, there's your range hoods and supplemental bathroom fans, 0.1. So that's where you need to have your capacity ratings. These higher static pressures are going to improve our overall ventilation performance. So I'm happy to see those introduced. I think 0.2 was far too low for HRVs and gave the impression that the HRV might actually be able to do that with extended ducting, and we know that that's not the case. One other little new provision is that HRVs and ERVs that are used for any purpose in the design of a ventilation system shall have a very low temperature ventilation reduction factor that's less than 50%. This is to be based on the outdoor winter design temperature, or if it's not listed at that temperature, minus 25 Celsius in the HVI product certification directory. So what does that mean? So essentially what it means is when it's very, very cold, the HRV has to stop running to defrost. So there's a ventilation reduction associated with that. And there's a number assigned to that in terms of the actual laboratory testing that HVI does. So I'll read you their definition of this factor. So it's the percent reduction in airflow rate of the supply and exhaust systems in the last 60 hours of the 72-hour test compared with non-frosting conditions. The reduction in airflow results from frost and ice buildup in the exchanger and variations in ventilation rates during defrosting. So that's the reasoning there. So less than 50% is it's got to be you can't choose an HRV that has more than 50% low very low temperature ventilation reduction factor. So that means half the time it's not working. So we don't want that. We want it working in cold temperatures. So keep the numbers down. Most of the common HRVs I've seen fit that bill. So you'll just need to check the ones that you're used to using, what are those numbers, and hopefully they're good and you can carry on. So small little item there. Ventilation ducts, they have all the usual installation requirements, but there's a new table for duct sizing for ventilation branch ducts and trunks. And the only other note, I'm going to take you to that table in a second. The only other note in this section is that exhaust openings within 3 meters horizontally of a range shall have a grease filter. So of course your range hood has a grease filter. If you have an HRV intake within 3 meters, 3 meters is 10 feet of a range, then it shall too have a grease filter. And that's commonly what we use in kitchens anyway. And probably best practice is just keep doing that, always require it. Here's our table. So this table is based on the static pressure that you're using. This is for HRV, exhaust fans. You could use it for range hoods, but our airflow doesn't go higher than it does. It goes up to 200 CFM. So this one's in metric. And I guess I'm going to take you to the imperial one in just a second. So it's based on static pressure and inches of water column. This one's in PA. The length from the hood to the grill is measured, and we double the flexible piping. So when we're talking about grill to hood on an HRV, we've got the hood, flexible piping to the HRV, then from the HRV to wherever it's going, whether it's the return air system of a forced air heating system, or if it's going to bathrooms, bedrooms, wherever it's going, you're measuring those total lengths. And the trunks, for trunks, we use the longest branch that's served by that trunk to do the calculation. And these tables show you the maximum airflow that can be achieved. So here's the imperial version. And what I like about this is it's easy for everyone to confirm that the sizing is adequate. So you don't have to be a designer to use this table. If you're an inspector or if you're reviewing a design or an installation, you can walk through and make the calculation yourself and have a look at the table to just make sure it's okay. So it's pretty easy. It makes it flexible for everyone. I've actually found myself using this table is taking the old W6B form that I used to use is now, starting to collect dust because this is so much faster and easier to do 90% of the time. So I hope you'll give that some practice and see what you think about it for your own designs. There's a new table that's just a little more elaborate with our equivalent sizes. And just a reminder that we're always talking about equal friction and capacity when we're looking at this, not cross-sectional area or velocity. So we're basically, we're replacing round, which is the best, way to convey air, to rectangular, which is less efficient, less effective method. So because of the corners, right? You got a nice round pipe, it makes everything flow well. So that's all taken into consideration when we do that. And then oval equivalents, there's a table in the 932 manual, the new one, and you can take a look at that or follow manufacturer's instructions, of course. And there's our imperial version. And then in 932.312, we get a lot of detail about HRVs. It's all the usual things that we've seen before, so duct sealing and all the rest of it. The 55% sensible recovery efficiency rule has been eliminated, so no longer caring about that. We've got SB12 and it already exceeds that, so we're going to be using those numbers instead. The one thing it does take in is that enthalpy recovery ventilators, what we commonly call ERVs, are specifically recognized as just another type of heat recovery ventilation device. So when you say one, it includes the other anywhere in the descriptions and in the code. Outdoor ventilation hoods, soffit blocking. Oh, sorry about my typo here. So soffit blocking, when you have exhaust ducts in a soffit or close to a soffit, the soffit must be blocked so that the warm, moist air that's coming out of the exhaust duct doesn't just get drawn into the attic where you're trying to, into the soffit, which you're trying to use to ventilate the attic and cause problems there with mold, etc. This is kind of one of those common sense things that we always knew, but wasn't actually ever written into the code. So if your distance between the exhaust outlet and soffit is less than a foot, then you'll need to have 12 feet of continuously blocked soffit. So you can still have your decorative looking soffit, but inside, above that, it needs to be closed off for 6 feet on each side of the exhaust outlet that's within 1 foot. And so as you move further down, further away, up to 6 feet, you get into needing less blocking, and after 6 feet, no blocking required. So if you got a 2-story and you've got a main floor bathroom that you're venting outside, chances are you're not going to hit a soffit. You're going to be further away than 6 feet. So you won't have an issue, but it's a second floor, or if it's a bungalow, you're going to have issues with your venting. So do again get this into your reports, because it's here now, and the jobs that we're doing today are going to be installed, tomorrow, and inspected the day after that, and that's when it'll, come to be, and no one will like that it wasn't on the original report. So that's another thing to be adding to reports right away. Yeah. And then we have another table, a new table that gives you the area of the opening for hoods with screens or grills. So when you incorporate some kind of a screen or grill on your opening, then you'll need to increase the area of the opening for that. So there's the numbers there. And we're getting close to time, so I was just trying to move things along. I do see questions in the chat, and no worries. I've got a little extra time after, so we'll get all your questions the best we can. So just to let you know, we're just about to wrap up here. So HRAI does offer training in National Building Code 932. We've been doing that now since last fall. And it has full exercises with various scenarios and some worked examples. That certainly makes it easier for you as a designer to, see all of that. In addition, we have an OBC 932 updater course. So if you are currently certified, and you're on the list of certified individuals, and you've got your OBC 932, and all of this is just like too much, you can purchase the self-paced self-study course. It comes with an exam. I believe the digital manual is also included, and you still can buy the hard copy for an additional fee. Which, if you are successfully, successful candidate in completing, writing the exam, getting through that, and completing the course, then you'll get a certificate that'll actually take you to our next recert deadline, 2031. So to me, that means that when all of us have our certificates now, they expire in December 2026. We should all have those. That's for all of our courses. We have a every 5-year renewal. That would mean that when the renewal comes up, you don't have to pay to extend the certification to 2031. So I think this is kind of an incentive to, it's just these are small costs normally, but it's an incentive to look at that updater. So if that's you, then go ahead and follow up. Just Google OBC 932 updater HRAI, and it should take you right to the registration forms for that. Ventilation with CSA F326 is another option. It's an advanced course. So it will basically, since it's part of the building code, you can use that exclusively, and you don't have to worry about whatever comes into OBC in terms of 932. It gives you some excellent additional tools for ventilation systems with higher complexity levels. And of course, it's accepted across Canada. So if you use that in another province, you should have no problems there. You can always check the website and contact HRAI's training department for courses. It is June, so we don't have much going on. I don't know. I didn't check before today to see if there is still anything left in June. I think most of the courses are done, and we resume in September. So we'll take the summer off. But if you did want more, you can also look at other kinds of training. There's lots of training available. Certainly all the BCIN training continues year round. If you're looking for a copy of the new Ontario Building Code, you can actually sign a declaration that you won't use it for commercial purposes, which just means you won't, make copies and sell them. You can certainly use it for your own understanding of the code and educational purposes. So no worries there. You just sign a declaration, and you can download both compendiums for free, which means you get all of the supplemental bulletins as well as the base code. I've got the code book here behind me. two great big volumes, about 1,200 pages. If you want to get a copy, it's a good time and good investment now because we're going to use it for a while. It's $195. And that also includes, I think there's one or two initial amendments that didn't make the printing, and those will be sent to you for free. And then after that, you just purchase the amendments as they come up and add them to the code. So you'll always have something hard copy that you can write on and all the rest of it, which I like. National Building Code, if you're interested, you can get that for free or paid under the NRC Publications.Canada website. And I believe certainly we'll have a video copy of this presentation, so you'll be able to get that from there as well. If you're an HVAC designer and you want to know more about the HVAC Designers of Canada, or if you're a building official, look us up, hvacdc.ca. Building officials get free membership, and in order to do that, you just need to have an email address that is, at a certain municipality, right? That's the way we know. You could become a member if you're not a building official, of course. You can become a member. You can you can just get on our email list for free, attend our technical talks. We do those monthly. We've got one left for the month of June, and then we take July and August off as well, start again in September. You'll find our F280 certified software list on the website. If you become a member, you can find and look at our our past technical talks. They're not old, actually. They're fresh, a lot of them. And we've done, I don't know how many talks are on the website, but we've been doing them since 2020, 2021, and recording them from about 2022, 3 on. So there's quite a lot of topics there of interest. We've also created a certified designer registry, and we're taking applications for that. So if you're certified with HRAI, you're hanging out your shingle, you have insurance, this is where to be. This is where building officials are going to see that you are credentialed, and also they're using it as a way of giving references without having to endorse anyone specifically. So it's the place to be. It's building, and we're in the infancy now, so get on in. If you need to contact me, there's my contact information. I'm always happy to take questions. Yeah, anytime. And so I guess, Matt, we can turn it over to questions,
Yeah,
and I'll just
wonderful.
stop sharing. Yeah.
Yeah, we've got several questions, and
I
we're
see.
we're up to time, but happy to stay a little later and answer as many as we can. Sure. So I'm going to go to, if you'd like to ask a question, please put that in our chat or the Q&A button as well. There's a couple technical questions, Jeanine, so I don't know if you have the chat open.
Yeah.
I just know I'll
So
mess that
I
one up, but
do. Yeah.
yeah.
So Ahmed, I'm just starting at the top here. So
Sure.
Ahmed, you were saying the utility room usually not normally ventilated. Do you mean forced ventilation or because it's a non-occupied area? Yeah. So utility rooms, you don't need to ventilate the space if it's part of a secondary suite arrangement. If the utility room is a room in the building, then it should be served by forced air, right? Unless it's a non-forced air system, then in which case, then it wouldn't need ventilation. One thing that always has stuck in my mind, is the concept that really all rooms and spaces need ventilation. So we know what happens when we have rooms that don't have air moving through them. The quality of the air is certainly compromised, and the potential for mold, especially in the summer when the rooms they gather moisture and it's not ventilated away, it can lead to problems down the road. So if we can at all, we try to get into all the rooms, but you're absolutely right. If it's a non-forced air system, there's nothing compelling you at all within the code to provide forced air to that room, any fresh air to that room. But yeah, so you see what you can do. It's a case by case basis. And the other one, a self-circulating exhaust fan. Okay, that's the same as a furnace fan. Self-circulating, you can't really have a self-circulating exhaust fan. So I don't know what you mean by that. Um, so maybe we'll get you to elaborate on that, and I'll go to the next question. Um, yeah, so 50 CFM fan capacity is double of what is required in guest toilet. No, actually, that's the new requirement. Yes. Okay. Okay. So you're using a different method here, I think. You're saying that, oh, okay, times 3,600. Okay, so yeah, we don't use an air change rate for bathrooms that is, so many air changes per hour. We just use, it's just straight out 50 CFM is your bathroom rate. Now, if it's a principal exhaust fan, then it's 64, it's whatever the number of bedrooms asks for in terms of maximum minimum. And if that happens to be, if it happens that 50 CFM is right in the middle, you can certainly use that. So yeah, that's the way we go. If you're using HRAI in a small commercial building, you're going to get into some different numbers. So we're talking about residential dwelling units only within the scope of 932. So that's what we're using. But yes, HRAI has some different metrics. If an HRV is used as a principal exhaust fan, can the air volume exceed the maximum air volume? Absolutely. Yeah, I want to make sure that was clear. The minimum maximum for principal exhaust fan means that that's got to be available from the HRV on one of the speeds. So it doesn't mean you can't have another speed that runs higher. I would encourage that. So I want to make sure we're clear about that. That was something that right away people, so good for you, Rita, you jumped right into what a lot of people thought was the case, and they were quite concerned because they said, I've got 3 bathrooms I want to pull from. I can't do that with 60 CFM or 50 CFM for all 3. So I need something more powerful and effective. And so absolutely you can. We're just trying to make sure that one of the problems that we have, well, one of the big problems that we have is that we're designing systems for people who don't understand what the implications are of the design or how they work. So if we provide a system that doesn't have an ability to get into that low range, people will turn it off. They'll eventually get, either get an energy bill and say, this is costing me too much, like let's eliminate all the things we can eliminate, and they'll turn it off. Or the dwelling unit will become really dry if the occupant humidity donation to the space, i.e. cooking and showering, etc., doesn't contribute enough moisture to the space. And so then it starts to get dry, towards the end of winter. And then again, they turn it off. So we want to have those principal rates because that's what people need to breathe in terms of having enough oxygen. So we want to see those numbers in there. We want to see that as our continuous rate, but we certainly like to have the capability of, for a timed interval, 20 minutes, being able to crank it up to high and have bathrooms, get proper ventilation. So absolutely. The ductless, you mean the
That
ductless.
was in
Okay.
relation to the previous question.
Self-circulating exhaust fan. Okay. Oh, yeah. I'm still not really catching you here. You can't have an exhaust fan that circulates only. It's not
Ductless
exhausting.
range hoods, perhaps? They clarified here.
If it's a
Mhm.
ductless range hood, okay, I think, yeah, in that case, there really is no requirement. It's just a circulating, it cleans the air. A lot of them have a charcoal filter to kind of filter the air, but those filters need to be replaced, several times a year to keep them working properly. So more or less it becomes a task light and some kind of a defense, for the cabinetry against grease splatter, etc. But yeah, there's no real requirement. There's no airflow requirement there. It's not exhausting. And then the TVC is not shown. No, we don't have TVC anymore. So it's not on the worksheets anymore. No, so the two numbers now are your minimum and maximum principal exhaust fan capacities. That's your first number. And then if you want to have more air, you just provide it. The only time you have to have the 2.5 times rate is if your kitchen has an HRV intake and does not have a hood vented to the exterior, then you must uh, use 2.5 times your principal exhaust fan capacity with your HRV and have a timer in the kitchen, a push button timer that's labeled kitchen exhaust. So yeah, no more of that. So yep, ductless range. Yeah, ductless range hood. Thanks, Zainab. Definitely, that's not exhausting to the exterior, so it can be whatever you like. Yeah.
Thank you so much. We have a few more questions in the Q&A
Yep.
if you still have
Okay.
a few minutes.
Yep.
Yeah.
Sure. Yep. No problem. Let's see what we got.
Mhm.
So you would like to train for HVAC design, have an international mechanical engineering experience. Yep. So yeah, I mean, usually a lot of what I find with mechanical engineers is they're always focused on larger buildings. So they haven't really done residential. So definitely the first place to start is really with HRAI. Take the heat loss and gain course because that's a CSA standard, so it's specific um, to the uh, to the systems here in Canada. So it's based on an ASHRAE standard, or sorry, the ACA Manual J, and which some engineers might be familiar with, but definitely use the CSA method. And from there, you look at air system design, all of the things that HRAI teaches and provides certification for are referenced in the building code. So you can use those tools and they are in compliance with the code. So that's the place to start, and you work your way through. You can look at getting your RASDT certification, which is your residential air system design technician. And I believe you need pardon me, 4 or 5 courses to complete that. I think it's 4. Minimum CFM for principal exhaust is not intended to limit HRVs, Steve. Absolutely. I think we've already covered that. And no, the whole issue, no, don't get that wrong. The whole issue about over ventilating, you're not going to over ventilate in the minimum maximum range. Not at all. And you're not going to over ventilate if you want to have the HRV come on to high for periods of high moisture. Either your dehumidistat is saying, hey, we need to get rid of some moisture in here. You've got a higher occupant load, you're doing a lot of cooking, whatever the reason for that, you want to be able to have that. So we want ventilation systems that have flexibility. And so definitely you probably read the appendix, and that's where that got misinterpreted. It's definitely not to limit your HRVs. It's meant to limit your principal exhaust fan. So people don't just go and say, okay, 3 bedroom, 60 CFM. Well, I'm going to use a 200 CFM fan. So that's where the problem comes in. Does soffit blocking apply to kitchen hoods? Absolutely. Any exhaust fan, almost all of them are removing moisture. And we're always thinking about winter time. So that's everything. That's dryers, exhaust fans, kitchen hoods, HRV exhaust hoods as well. So all of those. A customer installed a 1200 CFM kitchen fan. They don't require a makeup air. Actually, it's not a must. But this is a case by case thing. So if every appliance in the house is direct vent and there are no wood burning appliances, then there's no reason to be concerned with depressurization other than, you would like to open the front door. Um, and I just say that as a joke. But oftentimes these 1200 CFM fans, it's not one speed. So you don't just, turn it on and boom, 1200 CFM. Usually there's a dial up, and usually by the time you get up to the higher end of the possible range for that range hood, it gets really loud. And so most people will not want to experience that other than if they just burn dinner for very long. And so they'll usually be turning them down, and hence the reason that it's not normally required. Now, that is the kind of hood that would be used for a small restaurant. So, a little bit of discussion about can we cut that air in half? Are there two fans? Can we just run one? What can we do to reduce that? A little bit of homeowner education, but more or less, there's no specific requirement that says you need to make up air. Let's see. Rick asks, for more than 5 bedrooms, you can use ASHRAI 62 or only F326. You can use either. Yeah, either one is acceptable. They're both referenced in Part 6 of the code, meaning that both of either one can be used. Yeah, no, and Rick, if you go to Part 6, you're in Part 6. You're out of 9. You're out of 932. The heating season ventilation required by clause shall be provided by mechanical ventilation. Okay, now 932 1B. So why does it, so I think you're asking, okay, I think we've got it there. Rick, I think you're okay. And the anonymous attendee who's asking about City of Ottawa and the 1200 CFM range hood, because they are the authority having jurisdiction, it's their prerogative to ask for it. But you can point to, the code and say, or ask them for the code reference that refers to that, whichever way you want to approach it. Or you can point to, we don't have to have it except for these conditions, and those conditions don't exist. So you could support it with your own argument, or you could ask them to code reference. But either way, they are the authority having jurisdiction, and so they certainly can ask for it.
Thank you so
I
much for
think
going
that's,
overtime with these questions.
yeah, no problem. No problem. I have a meeting at 1:30, but I still have a few more minutes. So
I want to make sure we got all, and there was one more placed in the chat, how to ensure non-heating season. Did
oh,
we cover that one?
how to ensure non-heating season ventilation rate meets the 932 table? Well, of course, because it is a mechanical, if it's mechanically cooled, so you're using mechanical ventilation to do this. So the product that you choose, if this is your, again, you're not really going to have principal fan, supplemental fan, but whatever fan you choose would have to be able to provide that. So you can look at the specs. I would suggest that you're using maybe 0.25 inches of water column if you're looking at the specs to pick a fan. But then once it's installed, you could measure it by using anemometer, or a digital manometer, and, taking a pressure drop. I guess there's a way to perhaps do that. Probably the best way is an anemometer at the hood, and just, see if you're getting an airflow that would suggest for that pipe size that it's actually conveying that amount of air. So yeah, we're usually talking about, when we talk about non-heating season ventilation buildings, we're generally talking about a building that doesn't have power, that's maybe used like it's a little cabin, off-grid cabin, and all of the rooms that have windows and doors, are covered. So you're just talking about one interior room that might not have any actual ventilation. And if that's a bathroom, then you probably just want a bathroom fan. And so that might exceed your requirements anyway. So yeah, that's basically it.
You've done a lot, answered a lot of questions, and provided some great information. So thank you so much, Jeanine.
Thanks, Matt.
And you'll be back Thursday to do it all over again.
Yes. Yeah,
Yeah.
Thursday we cover everything outside of 932.
Okay. So if you want to join that, please register now. We got a lot of people already. And
Mhm.
we will see you back here in a couple of days. Thank you so much for your time.
Okay, thanks. Have a great afternoon.
You as well. Cheers.